Hello, people. Good morning. Good morning. Good morning. Good morning. Good morning. Hello, Abhinav, Shivam, Riyan, Mukesh, Ramcharan. Good morning. Good morning, everybody. Good morning. Good morning. Good morning. How you people are doing? Kaisen ba? Very good morning. Very good morning. Let people join. Just majama. Hello, Arvind, Darshan, Ria, Akshay. Welcome to the class. Good morning, people. Ashutosh, Avinash, Bala, Mahesh. Good morning and welcome. This is the beauty of live classes, no? That I can address all of you by your name. Ashutosh, good morning, good morning. Mahesh, good morning. Good morning, people, good morning. Good morning, good morning. Chalo, chalo. Let's wait for 1 or 2 more minutes because whosoever have to join timely, let them join and then we'll start. Okay. So today we are going to study about something that is very important. That is very important uh, foundation in fluid mechanics. In fluid mechanics, almost 70% of the syllabus requires calculating the volume flow rate and the discharge. Hello, Anil. Hello. Welcome to the class. Mechanical guys can also attend it. Yes. This is for both mechanical and civil. This is for both mechanical and civil. Hello, Yug. Some sessions on dynamics concepts of engineering mechanics. Okay, dear. I will plan. Hello, Krunal. Hello. Welcome to the class. Beard suits you. Nice look. Thank you. Yes. आज से मशीन डिजाइन हाँ जी आज शाम से मशीन डिजाइन का युद्ध स्टार्ट है टुडे इवनिंग वी आर गोइंग टू स्टार्ट मशीन डिजाइन एफएम मैराथन क्लास कब है अरे एफएम का जो बाकी बचा हुआ है एक मैराथन क्लास ली थी मैंने चलो वो भी प्लान करता हूँ डिजाइन सेंसेशन हेलो अनूप वेलकम टू द क्लास हेलो हेमंत वेलकम टू द क्लास रविंद्र वेलकम टू द क्लास संघर्ष जारी रहे हेलो वेदांत वेलकम टू द क्लास यशवंत आ जाओ धनुष सुनील विवेक नेहम वत्स वेलकम टू द क्लास हेलो हेमंत गुड मॉर्निंग सर एक पोएम प्लीज लुक घोस्ट राइडर ओह one lesson on Goodman criterion of machine design. Okay. Hanumanji. Oh, Hanumanji is the son of Marut. Marut stands for Pavan Dev. Marut stands for the god of wind. Hello Rishabh, hello Ilyas, hello Shubham, hello Bhavani, welcome to the class. Roop Kumar Mahanti, welcome to the class. Rakesh, Ajao. The god of fluid. Yes, the god of compressible fluid. हेलो ऋषभ खुश रहो आबाद रहो मस्त रहो आगे बढ़ते रहो वैभव गुड मॉर्निंग साई आ जाओ अहम ब्रह्मास्मि त्रिवेदी अहम ब्रह्मास्मि खुश रहो अनूप मस्त रहो मजे करो चलो, hello people, hello. How are you? I'm good, I'm good. As always, as usual, I'm good. Okay, let's go ahead and start doing our bit. So what exactly is the volume flow rate? First of all, I'm going to tell you about volume flow rate. First of all, I'm going to tell you about volume flow rate, that what exactly, how to prepare DRDO mains. Acha ji, I'll do. Sai. So first of all, we are going to discuss about volume flow rate. Are people are still joining in. आ जाओ जल्दी से आ जाओ. Naseem, Saurabh, Harsh, Prateek, Nitesh, welcome to the class. People, Shushrut, welcome to the class. आ जाओ आ जाओ आ जाओ. चलो, we'll wait for 2 more minutes. Finally, because मैं चाहता हूँ कि एक बार स्टार्ट करूँ तो फिर फ्लो ना टूटे, है ना? जैसे ही मैं स्टार्ट करने चलता हूँ, somebody pops up. ये देखो, ये देखो, ये देखो, रुक ही नहीं रहा है सिलसिला. गुड मॉर्निंग दीपक, गुड मॉर्निंग, गुड मॉर्निंग, गुड मॉर्निंग. कल अच्छे से समझ में आया था. हाँ, आधे घंटे के लिए, हाफ एन आवर के लिए I'll disable the commenting so that we can learn uninterrupted. And then कल भी तो मैंने डाउट्स क्लियर ही किए थे आपके. So I'll clear the doubts, don't worry. From today you'll start machine design. Yes, from today I'm starting machine design 5 to 7. Is it complete course or what? Yes, it is complete course. It is going to be comprehensive course aimed for both GATE, ESE, everything. GATE, ESE, everything. Hello, Manvendra, Sanket, Prince Kashyap, welcome to the class. आ जाओ आ जाओ आ जाओ. चलो, तो अभी स्टार्ट करते हैं. लेट्स नाउ स्टार्ट. गुड मॉर्निंग महाकाल ऑफ मैकेनिकल. अरे भैया, सिद्धार्थ, आनंद, विकास, वेलकम टू द क्लास. थैंक यू सो वेरी मच. ओके, गुड मॉर्निंग, गुड मॉर्निंग, गुड मॉर्निंग सिद्धार्थ, गुड मॉर्निंग मानवेंद्र. ओके, नाउ विल स्टार्ट फाइनली. लेट द पीपल ज्वाइन. इसके बाद अगर कोई ज्वाइन करता है तो ज्वाइन करता रहे, आते रहेंगे लोग. अभी स्टार्ट करते हैं. You see, as I said, from the fluid kinematics to fluid dynamics to velocity computation to Bernoulli's equation to momentum equation to angular momentum equation to turbo machinery, discharge is something. Discharge is something. Volume flow rate or discharge, my dear friends, is something that is needed in 70% of fluid mechanics. That is needed in 70% of fluid mechanics, study, whether you study pipe flow or you study flow over a flat plate or you study flow between parallel plates or you study flow over weirs, notches, or you study open channel flow. Discharge is something that is one of the backbones of discharge calculation is one of the backbones of fluid mechanics, which is needed everywhere, wherever the motion of the fluid is involved. Wherever the motion of the fluid is involved, discharge calculation is needed. So suppose there is a motion of the fluid happening. Suppose there is a motion of the fluid happening. Suppose there is a motion of the fluid happening. Suppose there is a motion of the fluid happening. Suppose there is a motion of the fluid happening like this. Suppose there is a motion of the fluid happening like this. So these directions are basically representing the velocity directions. These directions are basically representing the velocity directions. बहुत ध्यान से समझियो. These directions are representing the velocity directions, the velocity directions, the velocity directions, the velocity directions at any given point. But suppose I want to calculate the volume that is flowing through this particular section. I want to calculate कि कितना volume 1 सेकंड में इस सेक्शन से पास हो गया. Okay, I want to calculate that how much volume is passing through this section. Good morning, Junaid. Good morning. Good morning. Aa jao. Hello, people. Good morning, everybody who has joined the class now. Good morning and welcome. A very good morning to all of you. Let's learn about this. अभी 2 मिनट में मैं बाय बोल दूंगा. मतलब बाय बोलने का मतलब जाऊंगा नहीं कहीं भी. Comments disable कर दूंगा. In 2 minutes, I'll disable the comments for half an hour so that we have some fruitful learning. And उसके बाद फिर से enable करके आपके doubts clear करूंगा. Then I'll enable the things and I'll clear your doubts. Good morning, people. Good morning. Chalo. Shall we say bye now? Shall we say bye now? Bye. Okay. Bye. See you after half an hour. After half an hour, see you. Chalo. Bye bye. सो माय डियर फ्रेंड्स, बहुत ध्यान से समझियो. मैंने बताया आपको कि वॉल्यूम फ्लो रेट या डिस्चार्ज जो है ना, ये हर जगह चाहिए होता है. दिस इज नीडेड ऑलमोस्ट इन एवरी फील्ड ऑफ फ्लूइड मैकेनिक्स, every domain of fluid mechanics. What exactly is discharge? What exactly is volume flow rate? Volume flow rate is nothing but the volume that is going to flow. Volume that is going to flow per unit time. Volume that is going to flow per unit time. So suppose we have this velocity field. Suppose ये velocity field है, ये flow हो रहा है. Suppose this flow is happening here like this, like this, like this, like this, like this, like this. And then we want to calculate the volume flow rate through this particular section that I have taken here. Through this particular रैंडम सेक्शन, कोई भी रैंडम सेक्शन मैंने इस तरह से एक ले लिया और इसके थ्रू मुझे वॉल्यूम फ्लो कैलकुलेट करना है. ध्यान से समझियो, बहुत ध्यान से समझियो. माय डियर फ्रेंड्स, you have a look here, you have a look here and see that the velocity is like this. See that the velocity here is like this. Now this velocity here is going to have, this velocity here is going to have two components. One component is this velocity here. जो फ्लो की वेलोसिटी है ये, इस वेलोसिटी के दो कंपोनेंट्स आप आइडेंटिफाई कर सकते हो. यू कैन आइडेंटिफाई two components of this velocity. One component along the tangent to the area and another component, देखो ये vertical area almost लिया है मैंने. I have taken this area almost vertical, but velocity is not purely horizontal. Velocity is not purely horizontal. इसलिए velocity के दो components होंगे, one tangential to the area and another perpendicular to the area. One tangential to the area and another perpendicular to the area. Let's call this perpendicular component by the name Vn, and let's call this tangential component by the name Vt. Hello people, welcome to the class if somebody is joining or whatever, but please stay focused. Please stay focused. This is the velocity, and velocity may not be perpendicular to the area that we are selecting. Just like, you calculate stress at inclined planes. Just like you calculate stress at inclined planes. Further clarify करने के लिए मैं आपको ऐसे बता देता हूँ. Let me clarify it further. That suppose this is the flow direction. Suppose this is the flow direction. 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 Suppose this is the flow direction. But suppose we want to calculate velocity at this section here. अब इस पे, इस सेक्शन पे velocity देखोगे तो इसके दो components दिखेंगे. At this section, at this particular point, you'll see two components. One component is normal to the area. One component is normal to the area. Another component is tangential to the area. Okay, one component is perpendicular to that area that you are selecting. अब area तो कैसा भी select कर सकते हो flow में. Area you can select in infinite possible ways in a flow. These are all imaginary areas. These are all, they may be real areas as well, but abhi ke liye they are imaginary areas. तो ये इमेजिनरी एरिया है कोई. अभी वेलोसिटी इज हैविंग टू कंपोनेंट्स, वन इज normal to the area, another is tangential to the area. And you think about it, the tangential area is never, the tangential velocity is never going to be responsible for any flow happening across the area. Tangential velocity is never going to be responsible for any flow happening across the area. It's like you enter into a room. It's like you enter into a room because the door is vertical, so you enter into the room always horizontally. कि डोर पे ऐसे 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 जाते हो, हाँ? Do you scroll over the door or what? हाँ? Do you crawl over the door or what? ऐसे 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 चलते हो? नहीं ना. So door is vertical, but you always move perpendicular to enter into the room. So your flow has to be normal. Then only you can cross that door. Then only you can cross that door. दरवाजे को क्रॉस करने के लिए आपको दरवाजे के परपेंडिकुलर मूव करना होगा. दरवाजे के अलोंग थोड़ी ना क्रॉल करोगे कि केचुए जैसे रेंगोगे दरवाजे के अलोंग. So you're not going to crawl along the door, and therefore do remember that tangential component is never responsible for flow across any area. Tangential component of tangential component of velocity is never responsible, is never ever responsible for, is never responsible for flow across the section. Only normal component of velocity is going to be responsible for the flow across the section. ठीक है. टेंजेंशियल कंपोनेंट की वजह से तो पार्टिकल उसी एरिया पे टहलता रह जाएगा. Due to tangential component, particle will be walking at that area only. It will never cross the area. Due to normal component of velocity, it will be crossing the area. Normal component of velocity, my dear friends, normal component of velocity is normal component of velocity is responsible for flow across the section. Cool. Now focus yourself here and try understanding. बेटे बहुत अच्छे से समझ लो. Why? Because this is a very important topic, and this is going to help you in so many things out there. So many things out there. अभी अभी समझो कि क्या है volume flow rate. What exactly is the volume flow rate? Volume flow rate is volume that is flowing per unit time. बहुत ध्यान से समझियो. Suppose this element is, let me change the color. Let me change the color. Suppose this element, my dear friends, is traveling through ds distance. This small element of the area, which is having dA value, this is traveling through ds distance in dt time. This is traveling through ds distance in dt time. dt time में ये जो dA area है ना, ये dt time में ds distance travel करता है. It is traveling ds distance in ds distance in dt time. Then how much volume it traveled in dt time? How much volume has been swept? How much volume has been swept in dt time? In dt time, my dear friends, in dt time, बहुत ध्यान से समझियो. In dt time, how much volume has been swept? चलो नॉर्मल वाला तो आप समझ चुके हो, तो ये मिटा देता हूँ. So that I have a little space left here. So that I have a little space left here. I'm saying it again, that tangential component of velocity is never responsible for flow across any section. Normal component of velocity is responsible for flow across the section. Okay, सिर्फ नॉर्मल कंपोनेंट ऑफ वेलोसिटी की वजह से फ्लो होगा, है ना। टेंजेंशियल कंपोनेंट की वजह से तो पार्टिकल उसी एरिया पे टहलता रहेगा। Due to the tangential component of velocity, particle will keep traveling along the same area. अभी आप बता दो मुझे बेटा, अगर dt time में you tell this to me, if in dt time volume that is being traveled is dA multiplied by ds, volume that is being traveled in dt time, जो volume आप travel कर रहे हो, the volume that you are traveling is dA multiplied by ds. dA multiplied by ds. Then in unit time, how much volume will be traveled? In unit time, how much volume is being traveled? In unit time, naturally, you are going to say the volume traveled is going to be volume traveled in unit time, my dear friends, is going to be dA ds divided by dt. dA ds divided by dt. But ds by dt क्या है? ds by dt क्या है? ds by dt is nothing but this. ds by dt is nothing but this normal component of velocity. ds by dt is nothing but this normal component of velocity. All right. So ds by dt is nothing. ds by dt तो normal component of velocity ही है भाई. देखो ना, distance traveled per unit time in this direction. So ds by dt is representing normal component of velocity, and therefore we get कि unit time में कितना volume cross कर गया, unit time में कितना volume cross कर गया, that we get unit time में कितना volume cross कर गया, that is vn multiplied by dA. But मुझे तो पूरे फ्लो एरिया पर देखना है. I have to see this at entire flow area. What should I do? I must integrate this. Over entire area to get the volume flow rate at entire area. पूरे एरिया पे अगर वॉल्यूम फ्लो रेट मुझे चाहिए, then I must, ये तो छोटू एरिया की बात हो गई ना बेटा. This is the matter of small differential area. ये छोटे से एरिया की बात हो गई. अभी मुझे अगर पूरे एरिया पे चाहिए फ्लो रेट, तो क्या करना होगा? If I want the flow rate at entire area, then I must integrate this. This, my dear friends, is the general way to calculate volume flow rate. This is the general way to calculate volume flow rate. Volume flow rate calculate करने के लिए ये एक general way है. Normal velocity ही count होगी, ये ध्यान रखना. Only the normal velocity is going to be counted. Please keep this in mind. Please keep this in mind that only the normal velocity will be counted, nothing else. Okay? Only the normal velocity will be counted as far as discharge is concerned. Tangential velocity kabhi count nahi hoga. If somebody joined late, if just in case somebody joined late, let me very quickly recapitulate. That what we have been talking about. Guys, आज का टॉपिक है वॉल्यूम फ्लो रेट, आज का टॉपिक है डिस्चार्ज, आज का टॉपिक है मास फ्लो रेट, एंड इस सेशन के एंड तक आप मास्टर हो जाओगे वॉल्यूम फ्लो रेट और मास फ्लो रेट. किसी भी तरह की प्रॉब्लम, एनी काइंड ऑफ प्रॉब्लम, एंड यू विल बिकम अ मास्टर एट वॉल्यूम फ्लो रेट एंड मास फ्लो रेट. And it is a compulsory thing. Why? Because angular momentum equation, it will be needed. Linear momentum equation, it will be needed. Energy equation, Euler's equation, Navier-Stokes equation, everywhere in the derivations and in the problems, it will be needed. But like, volume flow rate and mass flow rate, they are one of the most critical things, parameters, जो present रहेंगे ही. तो हमें जानना है कितना वॉल्यूम फ्लो होता है यूनिट टाइम में. एक फ्लो, एक फ्लो, एक फ्लो, एक फ्लो, एक फ्लो हमने डिफाइन कर दिया. We defined a flow. We defined a flow something like this. All right. Then we said that एक एरिया है, इसके थ्रू हमें जानना है कितना वॉल्यूम फ्लो होता है यूनिट टाइम में. सबसे पहली बात आपको ये समझनी है बेटा, सबसे पहली बात आपको ये समझनी है कि वेलोसिटी का टेंजेंशियल कंपोनेंट कभी भी वॉल्यूम फ्लो रेट के लिए रिस्पॉन्सिबल नहीं होगा, क्योंकि आप दरवाजे पे टेंजेंशियली मूव नहीं करते, आप दरवाजे के परपेंडिकुलर मूव करते हो तब कहीं दरवाजे को क्रॉस कर पाते हो. किसी भी एरिया को क्रॉस करने के लिए फ्लूइड पार्टिकल्स को उसके परपेंडिकुलर मूव करना होगा, ना कि टेंजेंशियल. If fluid particles are moving tangential to the area, then they will never cross the area. So therefore, tangential component of velocity is never responsible for flow across any section. Only the normal component of velocity is responsible for flow across the section. उसके बाद हमने इस छोटे से एरिया डीए पर फोकस किया जो डीएस अमाउंट से मूव करता है. दिस डीए एरिया इज मूविंग बाय डीएस अमाउंट. डीटी टाइम में कितना वॉल्यूम ट्रेवल हुआ, डीटी टाइम में कितना वॉल्यूम ट्रेवल हुआ, डीटी टाइम में वॉल्यूम ट्रेवल हुआ डीए मल्टीप्लाइड बाय डीएस. डीए मल्टीप्लाइड बाय डीएस यूनिट टाइम में कितना होगा, देखो ना, डीए मल्टीप्लाइड बाय डीएस, एरिया मल्टीप्लाइड बाय लेंथ, यूनिट टाइम में कितना होगा. What is going to be the volume traveled in unit time? In unit time, my dear friends, the volume traveled is going to be dAds divided by dt. dAds divided by dt. But ds by dt is what? ds by dt is nothing but distance per unit time. And distance per unit time is nothing but the velocity. इस तरह से हमें, और उसको फिर इंटीग्रेट कर दिया हमने, इस तरह से हमें फाइनल फार्मूला मिल गया. सो व्हाट इज द फाइनल फार्मूला, what is the final formula of discharge, what is the final formula of volume flow rate, what is the final formula of discharge, what is the final formula of volume flow rate. Final formula of discharge or volume flow rate, my dear friends, is normal velocity multiplied by dA. Sometimes ये तो जनरल फार्मूला है, लेकिन sometimes the normal component of velocity will be same everywhere. Sometimes normal component of velocity will be same everywhere. This is for any general case. This is for any general case, but sometimes uniform velocity at section will be achievable. Sometimes uniform velocity at section will be achievable. And if there is uniform velocity at the section, then you can take Vn out of integration. Okay, then you can take Vn out of integration. And if you can take Vn out of integration, my dear friends, if you can take Vn out of integration, then you will get Vn multiplied by integration dA. And integration dA is nothing but A. Integration dA is nothing but A. ये दो बातें याद रखो आप. जब वेलोसिटी यूनिफॉर्म हो, सिंपली एरिया इनटू वेलोसिटी. जब वेलोसिटी यूनिफॉर्म हो, सिंपली एरिया इनटू वेलोसिटी. जब वेलोसिटी यूनिफॉर्म ना हो, then please keep this in mind. Okay, now what about the mass flow rate? What about the mass flow rate? मास फ्लो रेट कैसे कैलकुलेट करेंगे? बहुत आसान है. वॉल्यूम फ्लो रेट मालूम है आपको. वॉल्यूम मल्टीप्लाइड बाय डेंसिटी क्या होता है? मास इज नथिंग बट डेंसिटी मल्टीप्लाइड बाय वॉल्यूम. अगर आपको वॉल्यूम फ्लो रेट मालूम है बेटा, if you know the volume flow rate, then you can calculate mass flow rate very simply. You can calculate mass flow rate very simply. So you are going to have mass flow rate क्या होगा? Mass flow rate होगा, mass flow rate is simply going to be the same formula, simply going to be the same formula. The same formula, just multiply by density. But this is the general case. This is the general case. But for uniform velocity as well as uniform density at a section, velocity भी constant रहे और density भी constant रहे, for uniform velocity as well as uniform density at a section, as well as uniform density at a section, my dear friends, rho will become constant, bahar kar do. Vn will become constant, bahar kar do. Rho will become constant, bahar kar do. Vn will become constant, bahar kar do. और दोनों को बाहर कर दोगे तो आपके पास बचेगा सिर्फ इंटीग्रेशन dA, and that integration dA will become total area. That integration dA will become total area. टोटल एरिया। तो वॉल्यूम मास फ्लो रेट के लिए आपको ये दो केसेस याद रखने हैं। फॉर मास फ्लो रेट यू विल हैव टू फॉर मास फ्लो रेट यू विल हैव टू कीप दिस टू केसेस इन माइंड। जनरल केस के लिए फॉर्मूला एक ही है बेटा, देयर इज ओनली वन फॉर्मूला एंड दैट फॉर्मूला इज लाइक एरिया इनटू वेलोसिटी, एरिया इनटू वेलोसिटी, mass flow rate, density into area into velocity, density into area into velocity. Now let me take some problems. Now let me take some good problems out there. कुछ problems लेते हैं and then you will understand the things. Then you will understand the things even more beautifully. So let me take some problems. कुछ problems लेते हैं अभी. As a very first problem, suppose we have the velocity defined. Suppose we have the velocity defined in a flow field. The velocity is defined as 3I. The velocity is defined as 3I plus 4J. The velocity is defined as 3I plus 4J. उस फ्लो फील्ड में बेटा ऐसा एक एरिया है हमारे पास, इन दैट फ्लो फील्ड ऐसा एक एरिया है, रे बंजा, ऐसा एक एरिया है उस फ्लो फील्ड में. An area like this is there in that flow field. The area has got the width perpendicular to plane of paper. The width perpendicular to plane of paper. ऐसा ये z direction है, okay? This is z direction and this is 1 meter. This is 1 meter and this, my dear friends, is 2 meter, 2 meter, 2 meter, 2 meter and 2 meter. What will be, एक flow field को इस तरह से describe किया गया है. There is a flow field that has been described like this. There is a flow field that has been described like this, and there is an area which is having height 2 meter and width perpendicular to the plane of paper 1 meter. That 1 meter is perpendicular to the plane of paper, okay? Then what will be the volume flow rate? What will be the volume flow rate through this AB area? What will be the volume flow rate through this AB area? ये आपको बताना है. Option A is ध्यान रखना, resultant velocity होती है अंडर रूट यू स्क्वायर प्लस अंडर रूट. अगर मालूम है आपको बहुत अच्छी बात है, नहीं मालूम है आज से मालूम कर लो. resultant velocity का magnitude, resultant velocity magnitude is अंडर रूट vx स्क्वायर प्लस vy स्क्वायर. तो इस तरह से रिजल्टेंट वेलोसिटी आप कैलकुलेट कर सकते हो. सो ऑप्शन ए इज, माय डियर फ्रेंड्स, दैट वॉल्यूम फ्लो रेट इज, option A is that volume flow rate is 6 meter cube per second. Option B is that volume flow rate is 8 meter cube per second. Option C is that volume flow rate is 10 meter cube per second. And option D is that volume flow rate is none of the above. Chalo. Now you participate in the poll and answer your result. It should be calculated within 1 minute or something. Good, 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 good. Very good. 60% people got trapped. इतनी देर से बता रहा था मैं यार, आप लोग क्या सुनते हो? 60% people got trapped. Correct option is 6 meter cube per second. Correct. Sorry. Really sorry. क्या लिखा है? क्या लिखा है? इसीलिए इसीलिए मैं कहता हूँ conceptual learning is needed. Conceptual learning is needed. बहुत 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 सिखाया गया आपको झूठ. बहुत सिखाया गया आपको झूठ. Area into velocity, area into velocity, area into velocity, and area into velocity is discharge. No. Area into velocity perpendicular to the area. Area into velocity perpendicular to the area defines the discharge. Defines the discharge. My dear friends, बहुत ध्यान से समझियो. U component is representing the velocity component in x and V component is I लगा है ना इसके साथ. I का मतलब हो गया horizontal. I means horizontal. J means vertical. So I unit vector means horizontal and J unit vector means vertical. This is X component of velocity and this is Y component of velocity. Y component of velocity is 4 meter per second. Now, on this particular area, my dear friends, on this particular area, only the U component of velocity only the U component of velocity will be responsible for the flow. Only the U component of velocity will be responsible for the flow. Flow के लिए इस एरिया पर केवल U component responsible होगा, केवल horizontal component responsible होगा. Vertical component नहीं responsible होगा. The vertical component is not going to be responsible. Vertical component is not going to be responsible. Vertical component is acting tangential to the area. And मैंने बड़े बड़े शब्दों में लिखा the tangential component of velocity is never responsible for the flow across the section. Tangential component of velocity is never responsible for the flow across the section. Normal component of velocity is responsible for the flow across the section. तो बेटा अभी आप फिर से दिमाग लगाओ जरा और देखो कि कौन सा कंपोनेंट टेंजेंशियल है और कौन सा कंपोनेंट नॉर्मल है. V is tangential here because your area is vertical. Your area is vertical, 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 vertical. Your area is vertical. इसलिए we will not be responsible, only you will be responsible. So what will be the volume flow rate? What will be the volume flow rate? Volume flow rate is going to be, अच्छा, velocity uniform है या varying है? Velocity is uniform or varying? Velocity is uniform. It is not varying. It's a uniform velocity. It's a uniform velocity. So this is going to be U multiplied by area. U multiplied by area. And U component is nothing but 3. So this will become 3 multiplied by 2. And you know what? मैंने इसीलिए रिजल्टेंट वेलोसिटी कैलकुलेट करना बताया था. इसीलिए मैंने रिजल्टेंट वेलोसिटी कैलकुलेट करना बताया कि आप फंसो. सॉरी. So this is the flow across AB area. This is the flow across AB area 6 meter cube per second. All right, अभी करते हैं एक ऐसी प्रॉब्लम जिसमें हमें इंटीग्रेशन करना पड़े. Now let us try solving one such problem in which we have to do the integration. Suppose we are having a flow over a flat plate Suppose we are having a flow over a flat plate, and my dear friends, ध्यान से समझियो, यहाँ से एक यहाँ से एक फ्लूइड की यूनिफॉर्म स्ट्रीम एंटर करती है प्लेट के ऊपर। यहाँ से एक फ्लूइड की यूनिफॉर्म स्ट्रीम प्लेट के ऊपर एंटर करती है। देयर इज अ यूनिफॉर्म स्ट्रीम एंटरिंग ओवर द प्लेट। ओके, एक प्लेट है और वहां से यूनिफॉर्म स्ट्रीम मतलब यूनिफॉर्म स्ट्रीम कहते हैं जिसकी वेलोसिटी स्पेस में चेंज ना हो। Uniform stream means that the velocity doesn't change in space. Now, as this fluid particle comes into the contact of the solid, as this fluid particle comes into the contact of the solid, ये जो सबसे नीचे वाला पार्टिकल है ना, ये सॉलिड के कांटेक्ट में आएगा। और जब ये सॉलिड के कांटेक्ट में आएगा तो सॉलिड तो रुका हुआ है, सॉलिड तो रुका हुआ है, तो इसके और फ्लूइड पार्टिकल के बीच का जो फ्रिक्शन है वो सॉलिड चाहेगा कि फ्लूइड पार्टिकल को भी रोक दे। सॉलिड चाहेगा कि फ्लूइड पार्टिकल को भी रोक दे, वो फ्लूइड पार्टिकल को रोक देगा, तो इसे कहते हैं हम नो स्लिप कंडीशन। इसे कहते हैं नो स्लिप कंडीशन, दैट जो भी सॉलिड है और उससे जुड़ा हुआ जो लेयर है वो सॉलिड की वेलोसिटी को ही एक्वायर कर लेगा। The layer which is adjacent to the solid will acquire the same velocity as that of the solid. जो सॉलिड की वेलोसिटी है वही वेलोसिटी फ्लूइड की वो लेयर में भी आ जाएगी जो जो सॉलिड की वेलोसिटी है और जो फ्लूइड लेयर उससे एडजेसेंट है। उसके बाद ये क्योंकि जीरो पर आ गया तो ये अपने ऊपर वाले पार्टिकल को रिटार्ड करेगा, ये उसके ऊपर वाले पार्टिकल को रिटार्ड करेगा, ये उसके ऊपर वाले पार्टिकल को रिटार्ड करेगा, ये इसके ऊपर वाले पार्टिकल को रिटार्ड करेगा। ऑलराइट, इस तरह से वेलोसिटी डिफरेंसेस क्रिएट होते जाएंगे। जो बहुत दूर बैठा पार्टिकल है वो अभी भी लगभग अनअफेक्टेड फील करेगा। बहुत दूर बैठा पार्टिकल लगभग अनअफेक्टेड फील करेगा इस सॉलिड बाउंड्री की वजह से। लेकिन सॉलिड बाउंड्री के आसपास वेलोसिटी डिफरेंसेस क्रिएट हो जाएंगे। ऑलराइट, ये इफेक्ट धीरे 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 पेनिट्रेट करता है एंड इस जोन को कहते हैं बाउंड्री लेयर। तो बाउंड्री लेयर में वेलोसिटी जो है ना वो वेरी करता रहेगा बेटा। बाउंड्री लेयर वेलोसिटी विल बी वेरिंग। ऑल राइट, सपोज एज अ सिंपलेस्ट पॉसिबल मॉडल, suppose the velocity is varying linearly as a simplest possible model। वैसे linearly वेरी करता है क्या एक्चुअली में? नहीं, नहीं, वैसे linearly वेरी नहीं करता है, but as a simplest possible model, suppose the velocity is varying linearly from zero value to to u, ये जो फ्री स्ट्रीम वैल्यू थी, ये वैल्यू इन डेल्टा हाइट, डेल्टा को कहते हैं बाउंड्री लेयर थिकनेस। दिस डेल्टा इज नोन बाय द नेम बाउंड्री लेयर थिकनेस। आपको पता करना है कि अगर प्लेट की विड्थ b है परपेंडिकुलर टू द प्लेन, if the width of the plane is if the width of the plane if the width of the plate if the width of the plate perpendicular to plane of paper is perpendicular to plane of paper is b, then what is the volume flow? What is the volume flow through this AB section? What is the volume flow through this AB section? अगर विड्थ है b तो वॉल्यूम फ्लो कितना है ए बी सेक्शन के थ्रू? व्हाट इज द वॉल्यूम फ्लो थ्रू दिस ए बी सेक्शन? अब यहाँ पे वेलोसिटी नॉर्मल है या नहीं? हाँ जी, देखो ये आपका एरिया है, दिस इज योर एरिया, दिस इज द एरिया और दिस इज द लाइन, दिस इज द एरिया और दिस इज द लाइन। वेल, you'll have to imagine it like this. You'll have to imagine it like this, that this is delta, and then you have the width of the plate perpendicular to plane of paper, perpendicular to plane of paper, and this is nothing but B. दिस इज नथिंग बट बी. अभी बेटा ध्यान से समझियो, बहुत ध्यान से समझियो. इसमें आपको इंटीग्रेशन करना पड़ेगा. इन दिस यू विल हैव टू डू इंटीग्रेशन, एंड फॉर डूइंग द इंटीग्रेशन यू विल हैव टू सेलेक्ट. फॉर डूइंग द इंटीग्रेशन यू विल हैव टू सेलेक्ट, you will have to select you will have to select a chotu area. For doing the integration, you'll have to select the Chotu area, a differential area. Let's say that differential area is available. बहुत ध्यान से समझियो. Let's say that differential area is taken at y distance, and that differential area is having the thickness dy. The differential area is having the thickness dy. Now, how the velocity is going to be at y distance? How the velocity is going to be at y distance? वेलोसिटी क्या होगी y डिस्टेंस पर? सिमिलर ट्रायंगल जिंदाबाद. सिमिलर ट्रायंगल जिंदाबाद. So u by y, similar triangle जिंदाबाद. U by y is equal to u infinity by delta. U by y is equal to u infinity by delta. From here, my dear friends, you can calculate that velocity is velocity is varying in y. How velocity is varying in y, ये आपको मिल गया. अब आप जनरल फंडा लगाओ. क्या जनरल फंडा? जनरल फंडा इज दिस. जनरल फंडा इज दिस. एरिया velocity into differential area. Velocity into differential area is the general funda. And now you can say that velocity is nothing but this, and differential area is how much, people? Differential area is b multiplied by dy. Differential area क्या है? Differential area है b multiplied by dy. Okay, so u multiplied by differential area, and then limit क्या होनी चाहिए y की? आप बता दो मुझे. What should be the limit of y if we have to cover this a b section? If we have to cover this a to b section, then what should be the limit of y? Limit of y must be 0 to delta. Limit of y must be 0 to delta. Now you put the value of u as u infinity divided by delta multiplied, and b भी बाहर हो जाएगा, and then you have y dy 0 से लेकर डेल्टा तक, 0 से लेकर डेल्टा तक, you get u infinity, and b divided by delta, and this will become y square by 2. This will become y square by 2 integration के बाद. So this will be 0 to delta, and you will be getting finally, इसको simplify करो फटाफट. Do simplify this as quickly as possible. Do simplify this as quickly as possible. And if you simplify this, you are going to get half u infinity multiplied by b delta, half u infinity multiplied by b delta. Okay, this is what you are going to get. Now ध्यान से समझियो, बहुत ध्यान से समझियो. एक चीट कोड छोटा सा समझ लो. Understand a cheat code, one little cheat code, and that cheat code is what? You calculate area under velocity profile, and then multiply it with the width to calculate volume under velocity profile. You calculate area under velocity profile and then multiply it with the width to calculate volume under velocity profile curve, और आपको result वही मिलेगा. You'll get the result same. This is a cheat code that's going to work as long as आपको volume calculate करना आ जाए. As long as you can calculate the volume under velocity profile curve, volume under velocity profile curve. So volume under velocity profile curve क्या है यहाँ पर? What is the volume under velocity profile curve? Volume under velocity profile curve is a triangular prism. Volume under velocity profile curve is a triangular prism. And my dear friends, अगर वैसे तो इंटीग्रेशन आपको यूज करना पड़ेगा, वैसे तो इंटीग्रेशन आपको यूज करना पड़ेगा, बट अगर आप वॉल्यूम कैलकुलेट कर पा रहे हो आसानी से तो इंटीग्रेशन की कोई जरूरत नहीं है. देयर इज नो नीड ऑफ इंटीग्रेशन, absolutely no need of integration. Just calculate the volume under this triangular prism. And what is going to be the volume under this triangular prism? What is going to be volume under velocity profile curve? The volume under velocity profile curve, my dear friends, is going to be half into delta into u infinity, half into delta into u infinity multiplied by b, half into delta into u infinity multiplied by b. You get the same result in one line. ये तो वैसे भी थोड़ा ऑब्वियस था क्योंकि वेलोसिटी प्रोफाइल लीनियर था. But now let me take the flow between two parallel plates. Now let me take the flow between two parallel fixed plates. The flow between two parallel fixed plates. One is the bottom plate, one is the bottom plate, another is the top plate. और इसके बीच से ध्यान से समझियो, बहुत ध्यान से समझियो, इसके बीच से एक यूनिफॉर्म स्ट्रीम एंटर करता है. A uniform stream is going to enter. A uniform stream is going to enter through here. यहाँ से एक यूनिफॉर्म स्ट्रीम एंटर करता है. तो अभी अभी जो मैंने डिस्क्राइब किया था, अभी अभी जो कुछ भी मैंने डिस्क्राइब किया था वो फिर से वैलिड होगा, वो फिर से वैलिड होगा कि यहाँ जीरो वेलोसिटी, यहाँ जीरो वेलोसिटी, धीरे 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 बीच में, धीरे 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 बीच की सेंट्रल लेयर्स की वेलोसिटी बढ़ती रहेगी. जो फ्लूइड पार्टिकल, the fluid particle that will come into the contact of the solid boundary will become zero, will become zero. And far away from the solid boundary, the effect will, motion effect will still be, motion effect will still be considerable. Far away from the solid boundary, the motion effect will still be considerable. There is one model and a very realistic model that suggests a parabolic velocity profile. There is one model that suggests a parabolic velocity profile, and this is given to you in the question. This is the central velocity, which is the maximum velocity. This is the central velocity, which is the maximum velocity. And एक मॉडल ऐसा बोलता है कि ये वेलोसिटी को y के साथ इस तरह से एक्सप्रेस किया जा सकता है if the origin is taken here and y is measured from here. If the origin is taken here and y is measured from here, then my dear friends, so what is b, by the way? B is half the depth. B is half the depth. B is half the depth. Okay. Then you calculate the volume flow rate. Volume flow rate through AB section. Then you calculate the volume flow rate through, you calculate the volume flow rate through AB section if the width perpendicular to plane of paper is W. Width perpendicular to plane of paper is, width perpendicular to plane of paper, width perpendicular to plane of paper, my dear friends, is W. Then you need to calculate Q happening through AB area, AB section. ओके, कैसे करोगे? बहुत आसान है. Velocity multiplied by differential area. Velocity multiplied by differential area. Velocity is what? Velocity is given to you u max 1 minus y square by b square. dA is what? Just like the previous case. Just like the previous case, dA is nothing but dy multiplied by width. dA is nothing but dy multiplied by width perpendicular to the plane of paper. dA is nothing but width perpendicular to plane of paper multiplied by dy, width perpendicular to plane of paper multiplied by dy, that is the dA value. All right, that is the dA value. Still कोई confusion हो तो मैं एक बार आपको एक cuboid लेकर बताता हूँ. Let me take a cuboid and then you will be able to understand. This is a cuboid or maybe a cube, and then my dear friends, you are calculating the area here. You're calculating the area here, here, the left face. So you are going to take z dimension multiplied by differential y dimension. Z dimension multiplied by differential y dimension. And then you have w into dy. लिमिट होना चाहिए माइनस बी से लेकर प्लस बी तक. Limit must be from minus b to plus b, because origin is, it's given that origin is at the midpoint. It's given in the problem that origin is at the midpoint with origin at midpoint. Okay, so this is what we have. अभी u max और w को बाहर करो फटाफट. माइनस बी टू प्लस बी, क्योंकि इवन फंक्शन है इसलिए इसको 2 टाइम्स 0 टू b भी कर सकते हो. दैट विल बिकम एन इजी थिंग, बिकॉज y पे स्क्वायर है इसलिए इसको आप 2 टाइम्स 0 टू b कर सकते हो. लिमिट को 2 टाइम्स 0 टू b. वैसे भी देखो ना, सिमेट्रिक है सब कुछ. अगर इतने के लिए कैलकुलेट कर लिया तो वही सेम कहानी इसके लिए भी एप्लीकेबल होगी. Same story is going to be applicable on the lower half of the area. Then you have W and you have U max and you have 1 minus y square by b square and you have dy. Now you take 2W U max. You take 2W U max out of the things and then 1 का इंटीग्रेशन हो जाएगा y and इसका इंटीग्रेशन हो जाएगा y क्यूब by 3b square. जीरो से लेकर b तक you integrate, you apply the limits, you get y minus y cube by 3b square. तो ये हो जाएगा b minus b by 3 which is 2b by 3, which b minus b by 3, हाँ, which is 2b by 3. So finally you will get 4 wb u max divided by 3. This is the final answer. This is the final answer. Now listen. Now listen. Subject to the condition that you know the area, subject to the condition that you know the area bounded by a parabola. You know the area bounded by a parabola. My dear friends, the cheat code is going to work like anything. The cheat code is going to work like anything. पैराबोला के लिए अगर आपको मालूम है बहुत अच्छी बात है, नहीं मालूम है आज से मालूम कर लो. मालूम है बहुत अच्छी बात है, नहीं मालूम आज से मालूम कर लो. That whenever you are having a parabola with zero slope, whenever you are having a parabola with zero slope at one end, then this area will always be bh by 3 and this area will always be 2bh by 3. Okay, where b is the horizontal distance, b is the horizontal distance and h is the vertical distance. h is the vertical distance. Okay, अभी देखो 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 पीछे तो देखो, ये एरिया हो जाएगा b into u max, b into u max divided by 3. But ऐसा एरिया नीचे भी है. Such an area is below also. So multiply by 2 to cover total area and further multiplied by w. Further multiplied by w. ले लो ले लो, नहीं 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 नहीं, ले लो आप. 4WBU max divided by 3 using simply the cheat code. हाँ, cheat code is subjected to a condition and that condition is that आपको volume under velocity profile curve calculate करना आना चाहिए तो ही ये काम करेगा. Otherwise integration जिंदाबाद. Welcome back everybody. I hope the session was useful for you and now you'll be able to calculate. अब आप किसी भी तरह की फ्लो सिचुएशन के लिए वॉल्यूम फ्लो रेट और मास फ्लो रेट कैलकुलेट कर सकेंगे. Now you'll be able to calculate volume flow rate and mass flow rate for any given situation. If there is anything that you want to ask quickly. जल्दी से पूछो. बढ़िया रिवीजन हो गया. फर्स्ट क्वेश्चन बहुत बड़ा ट्रैप था, मजा आया. कंटिन्यू फॉर 2 more hours, मजा आ गया. क्या ही तो बात है, आज भी मजा आया. एकदम सारे सब्जेक्ट्स में मजा आता रहेगा आपको. ऑलराइट, तो डोंट वरी, मटेरियल साइंस का क्विज है. बिल्कुल बिल्कुल बिल्कुल. ऑल द बेस्ट, ऑल द बेस्ट. Eagerly waiting for MD course to start today. Sure. Class was amazing. Thank you so very much. Amazing class. Thank you so very much. Dheeraj, meet at 10 on YouTube. Sure. 10 बजे मिलते हैं YouTube पे. FM के लिए बुक सजेस्ट कीजिए अगर फंडामेंटल से स्टार्ट करना है तो. FM के लिए बुक, इंडियन ऑथर पसंद है आपको या फॉरेन ऑथर्स पसंद है, आप बताओ. वेलोसिटी प्रोफाइल स्टैंडर्ड होगी हमेशा. वेलोसिटी प्रोफाइल गिवन रहनी चाहिए. यस दीपक, वेलोसिटी प्रोफाइल गिवन रहनी चाहिए, बट विस्कस फ्लो वाले चैप्टर्स में हम कैलकुलेट भी करते हैं. अमेजिंग, ऑसम, माइंड ब्लोइंग क्लास. थैंक यू सो वेरी मच. ओके, तो अभी ये वेलोसिटी प्रोफाइल वी एक्चुअली, फॉर एग्जांपल दिस वेलोसिटी प्रोफाइल कैन बी ऑब्टेन्ड यूजिंग नेवियर-स्टोक्स इक्वेशन. बट जब वॉल्यूम फ्लो रेट आप कैलकुलेट करोगे देन वेलोसिटी प्रोफाइल मस्ट बी गिवन टू यू. डायमेंशनल एनालिसिस का मैं कोई भी बोल दीजिए, कंसेप्ट समझ में आए तो अच्छा है. अच्छा, तो फिर सिंजल इज अ गुड बुक. सिंजल इज अ बैलेंस्ड बुक. और डिटेल में अगर एकदम मजा लेके पढ़ना है तो फॉक्स एंड मैकडोनाल्ड. Sinjil is a balanced book, nonetheless, is a good book. And is a balanced book. Balanced book मतलब ठीक है, मुझे बहुत पसंद नहीं है सिंजल as compared to some other books, but वो बहुत advanced हो जाएंगी इसलिए उनको मत ही पढ़ो. One book is Som Biswas and Chakrabarti, but I don't recommend it because that book is going to raise more questions in your mind rather than सम्स. के लिए सुब्रमण्या काफी है. हाँ, काफी है, मोर देन इनफ. जायरोस्कोप की स्पेशल क्लास. हाँ, वेयर विल दैट रिमेनिंग पार्ट गो. रिमेनिंग पार्ट कहीं नहीं गया, बीच की वेलोसिटी बढ़ गई. मैंने कभी नहीं कहा कि यू मैक्स इज इक्वल टू, देखो फ्लैट प्लेट वाले में कहा था कि ये यू इन्फिनिटी है और ये यू इन्फिनिटी है, हेमंत. बट यहां मैंने कभी नहीं कहा कि ये यू मैक्स इज इक्वल टू दिस यूनिफॉर्म स्ट्रीम. नो, बीच की वेलोसिटी बढ़ जाएगी. Umax is actually going to be more than this U naught. डिस्चार्ज जितना यहां है उतना ही यहां भी होगा. ओके, कॉम्पेंसेट हो जाएगा. हाँ, देखो कहीं डिस्चार्ज कम पड़ रहा है, कहीं डिस्चार्ज बढ़ चुका होगा. The central part velocity must have become more than free stream velocity. तो फ्लूइड के लिए I would say Sinjal is the most balanced book एंड और एडवांस्ड में जाना है देन FM फॉर FM, FM फॉर FM, FM फॉर FM, Fox and McDonald's. Som Biswas, no, I don't recommend. It's a good book nonetheless, but unnecessarily आप बहुत सारी चीजों में कंफ्यूज होगे, भटकते रहोगे. Is the session available on an academy later? Yes, yes, yes. It will be available. It will be available. After 2 hours, it will be uploaded. So please watch it. Chalo guys. Thank you so very much. Numericals के लिए सुब्रमण्य. Thank you for everything. You're always welcome, dear. Bye, people. हाँ मिलते हैं. Machine design, yes. Amazing class by amazing teacher. You guys are awesome. Chalo, people. Bye. Have a good day.